This is Algebra 2, Chapter 5, Unit 1, Part 1, Polynomials, Adding and Subtracting. First, let's take a short little review. A monomial is a number variable or product of numbers and variables. Some examples include 4, 7x, or 3x squared. Use the exponent rules to simplify monomial expressions. So here's the exponent rules. The first one is the product rule. So the product rule is saying that when a to the mth power times a to the n power equals a to the m plus n power. So let's take a look at what that means. We have x squared times x to the 7th power. So we are just going to add that 2 and that 7, and we're going to get x to the 9th power. This is all should be reviewed from Algebra 1. Next, we have the power rule. When we have a to the mth power, and then we're going to take that to the n power, we're going to just go ahead and multiply that m and n, and we're going to get a to the m times n power. So when we have x squared and we're raising that to the 7th power, we're going to get x equals 14 because we take 2 times 7. Quotient rule. When we take a to the mth power divided by a to the n power, we are really just subtracting that m and n. So we're saying a to the m minus n power. So if we have x to the 7th power divided by x squared, we have x to the 5th power. A negative exponent rule. So we don't like negative exponents, just like we don't like negative square roots. So we are going to take a minus to the negative m power. We're just going to flip that. So, or take the reciprocal. So we're going to say 1 over a to the m power, and that gets rid of that negative sign. So if we have x to the negative 2nd power, it's going to equal 1 over x squared. And notice how that negative sign is removed. Here's the zero exponent rule. We have a to the 0 power equals 1, and then a to the 0 equals undefined. So if we have 7x squared to the 0 power, as in our example, that's going to equal 1. When adding or subtracting monomials, always remember to combine like terms. Here are some examples. We have 5x squared times negative 7x to the 6th power. So first we're going to take a look at that 5 and that negative 7. And 5 times negative 7 equals negative 35. Then, since we're multiplying, we're just going to take x squared and x to the 6. We're going to add the 2 and the 6, and that is going to get us x to the 8th power. Now we have 2k to the 4th power times 10k to the negative 7th power. Okay, we have that negative 7, so we don't like that negative 7. So let's see what happens when we multiply this out. Well, 2 times 10 equals 20, and then we have k to the 4th times k to the negative 7th. Okay, so 2 times 10 equals 20, k times 4 and k to the negative 7, when we add those together, we're going to get k to the negative 3. Well, we don't like that negative 3, so if you remember with the negative exponent rule, we have to flip that. In this case, we're just flipping that k because that negative 3 is attached to the k only, so we're putting 20 on top and we're dividing that by k to the 3rd power. Number 6, we have 14w to the 12th power divided by 7w to the 3rd power to the negative 1 exponent. Well, if we go ahead and take it to the negative 1 exponent, we just have to flip those signs. So we flip it first, we do our exponent first, and we flip it. So we're putting 7w to the 3rd on top and 14w to the 12th on the bottom. Now we're going to go ahead and solve. 7 divided by 14 is 1, and then 14 is 2, so that reduces to 1/2. W to the 3rd and w to the 12th, well, that gets us w to the ninth on bottom. Now, why don't you try and solve numbers 2, 3, 5, and 7 through 8 on your own. Here are the answers to those problems. Go ahead and pause the video while you work them out. Now, they want us to give an example of two monomials with a quotient of -3 to the n squared power divided by m. So I'm going to look for something that I know that I can divide by each other to get -3. That's what I'm going to look for first. So I know that -36 when divided by 12 will get me -3. Now I'm looking for n squared. So my n on top has to be 2 greater than my n on bottom, okay, because it's positive. Next, I'm looking for that m to the fourth power, okay. I'm looking at m. So my m on the bottom has to be greater than my m on the top. And so notice that our m on the bottom is greater than our m on the top if we have m to the fourth divided by m to the fifth. So why don't you just pause the video, take a look, and see how that looks to you. Now let's move on to polynomials. A polynomial is the sum or difference of many monomials. The highest exponent of a polynomial is called the degree, and standard form is always write with exponents in descending order. And that's very important. The exponents have to be in descending order. It's saying going from 5, 4, 3, 2, 1, and so on. So let's write these polynomials in standard form. We have, for number 10, we have -k to the fifth minus 1 plus 8k minus 3k cubed plus 1/4 k squared. Well, our k to the fifth power has to come first because it's the highest exponent. So we put that in first. Next highest exponent is at k to the third power, so that comes in second. And then we have k to the second power, so that comes in third. And then we have a 1k right here with this 8k, so that comes in next. And then we have our integer. Our whole integers without any variables always come in last. Number 11. We have 18 squared b squared plus 7ab minus b squared plus 4a cubed. Well, you can pause the video, take a look, and see if you can figure this out on yourself. This one is a little bit different because we're dealing with two different variables. So an important thing to remember is that the variables also have to go in alphabetical order, meaning A comes before B and C. So we find our 4a cubed, which is also our highest exponent, and we put that first. Next we have, although we have a b squared here and a b squared here and an a squared here, this 18a squared b squared would come first because a comes before b. So we plug that in there. And although still we have that b squared as a higher exponent, a still comes before b, so we plug in 7ab next, and then minus b squared. Now let's pause the video and try number 12 on your own. Here is the answer for number 12. Now let's classify polynomials. Here are the charts to fill in on your sheet to classify polynomials. We'll first start with the degree. So if we have a degree of 0, it's a constant polynomial. If we have a 1 degree, it's linear. 2 is quadratic. 3 is cubic. 4 is quartic. And 5 is quintic. Now the number of terms. 1 is monomial, 2 is binomial, bi meaning 2, mono is 1, 3 is trinomial, and 4 or more is polynomial. Go ahead and pause the video while you write that down. Polynomials are classified by the degree, or the highest exponent and number of terms. Use the charts to the left of your sheet to classify each polynomial. So our first one is -3x plus 1. Well, we notice that this has a degree of 1 because there is a variable here, so it still has a degree of 1. So we know that it is a linear, and it has two terms, so it's binomial. It's linear and binomial. Next, we have number 16, 1/2 to the x times to the third power minus 2x squared plus 4x plus 15. This is number 16 on your sheet. Well, our highest degree would be this 3. Okay, so if we look at our chart, it's a cubic. It's cubic. And how many terms do we have? We have 1, 2, 3, and 4. So it's a polynomial. So it's a cubic polynomial. Now try numbers 14 through 15 and 17 through 20 on your own. Here are the answers for those problems. Thank you, and make sure you watch part 2 of Chapter 5, Unit 1.